Hello, welcome to today's lecture. Very well, we are starting chapter 3. We're going to talk about probabilities. So, what are the objectives of today's lecture? First of all, we're going to learn how to identify a sample space, understand what an event is, and finally, learn how to calculate simple probabilities. Well, let's start by some definitions. First of all, let's start talking about a sample space. Very well. When we're talking about probabilities, you're actually dealing with some experiments. So our very first step is having experiments. An experiment can include trials. For example, suppose you have just a coin and you start flipping the coin. You're looking at outcomes of flipping a coin, and in that experiment, you have some results or some outcomes. So you have an experiment. In that experiment, you look at the results of the experiment, and each result is actually an outcome of that experiment. So the collection of all possible outcomes is called a sample space. So definition of a sample space. A sample space is the collection, the set of, is a set of all possible results or outcomes. Give us one example. So, in this example, suppose you have a coin and we start flipping the coin. Let us flip a fair coin. You have two results, two outcomes. There are exactly two outcomes. The first outcome is having the head. The second outcome is getting the tail of the coin. So head is one of the outcomes. It's one of the results, comma. Also, you might end up with the tail. You never know. So we have to put that in set notation, and we say that we have the sample space of this experiment. Very well. What is the cardinality of this set or this sample space? So we're trying to connect what we're learning now by what we learned before. We're using set theory definitions. The cardinality of this set, or the size of this set, is equal to 2. Very well. What is an event? Or what is a sub-collection or subset of sample space? Look, we learned about sets before. We learned about concepts and some definitions. Now we're trying to use those definitions and actually expand our knowledge in probabilities and defining what is new, like a sample space, and actually using the information, the knowledge, the skills that we learned before to drive more information from a sample space. Well, since we learned about subsets, we can take a sample space and have the subsets of sample space and define something new that we call events. Definition of events. An event is a sub-collection or subset of a sample space. We usually denote a sample space by S. We denote a sample space by S. And for events, we can use A, B, C, E, F, and so on. The event, one event for sample space can be denoted by E, F, A, T. Is denoted by E and capital letters. Very well, we're going to get back to the example that we had. We had a fair coin and we flip it. We know that the sample space is equal to the set including head, tail. So let us denote this by S. So S is equal to head, comma, tail, and you're using the set notation. So the first event can be having head. So since it's a subset, we're going to write set notation for it. Event 1. Or another event can be having tail. So event comma 2 can be having tail. Two events or two subsets. Take a look at these two events. The cardinality of the first event or the size of the first event is 1. The cardinality of the second event is 1 again. The size of these two sets each is equal to 1. Note that we're trying to use the size of these subsets and the size of your sample space to actually define the probability of an event. For example, you might say, what is the likelihood having a head in flipping a coin? What's the percentage? What's the probability of getting tail by flipping a coin? So these are the questions that you're interested in answering by using the size or cardinality of the sample space and also the cardinality of those events. Let's take a look at another experiment. This experiment is on page 1 of the note. Example. So in this experiment, you're going to use a die and you're going to roll the die once. Suppose we are rolling a die once. Identify the sample space, and we're going to talk about a little bit of those subsets or events that we defined before. The sample space is the set of all possible outcomes. All possible outcomes. So very well. By rolling a die, what are the outcomes? Well, when you roll a die, you might have just a number like 1 or 2. It might be 3. Well, we can have 4. How about 5? And finally, 6. So you might end up with one of these numbers, either 1 showing up, or 2 showing up, or 3, or 4, or 5, maybe 6. You never know. Note that since we are forming a sample space, and sample space is the set of all possible outcomes, we have to use set notation, curly brackets. And note that we can denote this by S. S is the sample space, the set of all possible outcomes. Remember, you can always use Venn diagram to visualize your sample space. Venn diagram. We're going to list all of the possible outcomes here. 1, or 2, or 3, or 4, or 5, or 6. Now I want you to think about some of the subsets of this set. Well, these subsets can be, okay, just 1-digit values, subsets. Remember that you're just rolling this once, so you end up with 1 value. It might be 1, or it might be 2, or 3, maybe 4, maybe 5, maybe 6. Let's say, hey, I'm going to think about even numbers. Very well. It might be an even number, or you're thinking about the general concepts. It might be just an odd number. There you go. When you're talking about even numbers, it might be 2, it might be 4 or 6. When you're talking about an odd number, it might be 1 in this collection, or 3, or actually 5. The cardinality of the first subset of this set is 1. The cardinality of the second set is actually 1. You only see one member. The cardinality or size of the third set is also 1. The size of this set is 1. The size of this set is 1. And finally, the size of this set is 1. The cardinality of this set, an even number. This set has 2, 4, and 6. The cardinality of this set is 3. And as you guessed, the cardinality of the last set is also 3. You might say, hey, what if I work with numbers less than 3? Numbers greater than 3. Numbers less than 4. numbers greater than 4, or many different subsets. All of them are possible. So we can define different events for this experiment. Define many different events for this experiment. So on page 1, we have some events. Let us talk about those. So these are all possible events, but in this example, in our page 1, we have the following events. The first event, event 1, is 3 comes up. So how do we use mathematical notation, the symbols that we learned, to actually translate this into mathematical terms? 3 comes up. This is an event. Remember that. When you're talking about an event, event is a subset of your sample space. Subset. So we're going to use the set notation. 3 comes up. So this set has 3. Very well. Remember that for events, we can use capital letters like E, F, or we can use some indices to just separate them from each other. So I'm going to use E sub 1 to represent the first event. It says 3 comes up. The second event is an even numbers come up. Event 2, an even number comes up. Number comes up. Very well. I have my second event. So let me use index 2, E sub 2. And since an event is a subset, I'm going to use set notation. Very well. Even numbers in this collection, 2, 4, 6. So 2, 4, 6. This is my second event. And the last event says a number between 1 and 6 inclusive comes up. And the event, the third event, a number between 1 and 6 inclusive comes up. Okay, very well. What are the numbers in between 1 and 6 inclusive? It means that they are included. It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, and it can be 6 as well. So we can list all of these numbers, and as you guessed, this subset is nothing but the sample space itself. So event 3 is 1, 2, 3, 4, 5, 6, which is S, the sample space itself, of course. We defined subsets before, and we know that each set can be subset of itself. Well, now I expect you to think. You talked about sets before. Well, you talked about subsets, and you mentioned before that empty set, a set including nothing, is a subset of any set. How do you define that empty set here? Very well. In this example, we can say that what is the event of 7 comes up? So let me just write it here as a note. We can define an event like 7 comes up. Do you have 7 here? It's an impossible event. You say that it is an impossible event. An impossible event is denoted by empty set. So this event, you can call it E4, which is empty set, or if you remember, you can use curly brackets with nothing. Of course, the subset of any set, but this is impossible. So you might say, what's the difference between an event and an outcome? Well, note that there is a difference between an event and an outcome. What's the difference? An event is actually a subset. For an event, you're using curly brackets. An event is a subset of the sample space. How about outcome? Outcome is just a member. An outcome is a member of the sample space. So for an event, we're going to use curly brackets, but outcome is just a member, belongs to the sample space. Well, let us move on to page 2 and talk about the probability of an event. The probability of an event like E. Suppose we have an event like E, and we have the sample space S as a subset of sample space S. Is denoted by P of E. So you're going to use P representing the probability of event E. So you're going to write down event E inside parentheses, and it is defined. You have to use the cardinality of the event and the cardinality of the sample space. And it is defined as P of E equals to the cardinality of set E. So remember that for cardinality, we use N of E divided by the cardinality of the sample space S. Cardinality of set E divided by the cardinality of set S. The size of set E divided by the size of set S. Well, let us go over one example to actually understand how to use our probability. So I'm going to erase this part of the board. On page 2, we have an example. Let me write down the formula on this side for you. The probability of event A, P of E. Probability of event A is defined as the cardinality of event A and event E, N of E, divided by the cardinality of the sample space, or N of S. Well, we have an example. In this example, you have a fair coin, and that fair coin actually flipped. A fair coin is flipped. Find the probability of, so your first event says, find the probability of event E1 getting heads. Getting heads. And part B says, find the probability of getting tails. Getting tails. Very well. To follow the formula, first we have to identify the sample space, our denominator, then find the cardinality of the sample space. So what is S? S, or the sample space, is equal to the set collection of all possible outcomes. All possible outcomes, either head or tail. What's the cardinality of this set? It has two members, so N of S, the cardinality of S, is equal to 2. It means that your denominator is 2. We can write it this way. The probability of getting heads is equal to. So that collection includes one member, head. So you get 1. The cardinality of getting heads has only one member, which is head. So divided by 2, which is a half. A half is 50%. So you can either use percentage or we can leave it as fraction. How about the probability of getting tails? Sample space stays the same. It means that the denominator has cardinality 2. The denominator is 2. The probability of getting tails is, your denominator stays the same. Why is that? Because the denominator is the cardinality of sample space. Sample space is the sample space. It has 2 elements. So on the denominator, you get 2. What about your numerator? Getting tails, you only have one possibility. So the cardinality of your event is just 1, a half, which is 50%. 50% the chance of getting heads and 50% chance of getting tails. There is a simulation posted for you on Canvas, simulating the probability of a head. Very well, in this simulation, we have different options that we can select from. Flipping a coin, 1 flip, and the probability of getting head. You can just repeat this by flipping that 5 times or 1,000 times. Where is the probability? Where is the proportion? The probability or proportion is on vertical axis. So 0 probability, 20% probability, 40% probability. And as you can see here, you have 50% probability that we actually calculated that and we had it on the board. A half or 50% was the probability of getting ahead in the experiment of flipping a fair coin. You can repeat this process by flipping the coin 5 times. And 5 times. Very well. So as you can see, the probability shows a value related, associated to vertical axis. You can repeat this process 1,000 times. When you repeat that process 1,000 times, actually see this is convergent to the line, the green line related to the probability on vertical axis.